Hi, Caroline. I hope I'm pronouncing that correctly. Okay, I'm going to do the problem that you were talking about from the book. And first, to get some terminology correct, we have two polynomials, the 3x cubed plus 4x squared plus x plus 7, and we're dividing it by x squared plus 1. Now, each polynomial is made up of terms. Each one of these units is a term separated by, in this case, we have all addition. So I'm going to talk about terms and polynomials. This is the divisor. The x squared plus 1 is what we are dividing by. And I think that's it for terms. Okay, the idea is how many times does this x squared plus 1 go into the larger polynomial evenly? And there may be a remainder. So we look at the first term of each polynomial, and we want to know, what do we multiply x squared by to get 3x cubed? And the answer is 3x. And I'm going to do the multiplication up here. 3x times x squared plus 1 equals 3x cubed plus 3x. So this 3x cubed plus 3x term is a multiple of our divisor. So we're going to write that down underneath. But what we have to be careful about with polynomials is, does the degree of the term match what's above it? And if we were to write the 3x here under the 4x squared, they are not like terms. So we're going to move over, we'll just leave that blank, and we have a plus 3x here. I'm just going to erase that little smudge. So we are subtracting this multiple, 3x cubed plus 3x. It's a multiple of the divisor. We're going to subtract that from the polynomial. So as we planned, the first terms cancel out. Excuse me. We have a 0 here, so we have 4x squared minus 0, so we're left with the 4x squared. But we have x minus, over here, minus 3x, so we're left with minus 2x. And generally, we bring down the next term from the original polynomial. We bring it down here. Now, we're back to repeating what we just did. We're going to look at the first term, 4x squared, and this original x squared. What do we multiply the x squared by to get the 4x squared? So the answer is 4, a positive 4, which I should write in black. But we're going to do that multiplication, 4 times x squared plus 1 up here, and we get 4x squared plus 4. That's a 4. So again, this term up here, the 4x squared plus 4, is a multiple of our x squared plus 1. And we're going to write it here, 4x squared plus 4. Now again, we're subtracting this multiple of x squared plus 1. We're going to subtract it from this 4x squared term. So as we planned, the initial squared terms disappear. We essentially have a 0 here. So we are subtracting, we're taking negative 2x, subtracting 0, and we're still left with negative 2x. And then we have the 7 minus 4 is left with a positive 3. So now we evaluate again. We have this initial negative 2x term, and we have this, again, the x squared term. Now there's nothing you can multiply by except a fraction, I guess, which is irrational. We're not going to go there. Well, it's not irrational. It's just not a part of the, it's not a polynomial. So there's nothing we can multiply x squared by to get 2x. So we're done. But what does that mean? What it means is that the original equation, I'm going to stop this for a second and write the summary. So this is a remainder, basically, what's left over and cannot go in to the original polynomial. So our answer is 3x plus 4, and you could either say remainder negative 2x plus 3, or you can write it as a fraction, 2x plus 3 over x squared plus 1.